Greetings, this is Anthony Dick, just a walkthrough of the Math 1010 practice midterm, number 1. Okay, number 1, write the equation of a line slope intercept form. So that's y equals mx plus b form. That has a slope of 2 and goes through that point. So I'm going to start by, I'm going to use point slope form, which is y minus y1, which is the 4, equals m, so that's the 2, times x minus x of 1. So I use this one, y minus y1 equals m times x minus x1, where m is the slope and x1, y1 come from that point. So there it is. Now I can simplify it and change it to slope-intercept form. So I'm going to change that to addition. Y minus 4 equals 2x plus 6. Just distributed the 2 through there. Add 4 to each side. And I get my final answer, y equals 2x. And positive 6 plus 4 is plus 10. Multiply this. Distribution property. 3x squared times 2x. 3 times 2 gives me 6. X squared times x gives me x cubed. Negative 2x times 2x gives me negative 4x squared. X times x, yeah. Negative 1 times 2 is negative 2x. Somehow I feel like I'm missing something, but I got 3 terms, 1 term, all 3 terms. Yeah, that's it. So 6x cubed minus 4x squared minus 2x. Might just be too early or something. Simplify this expression, and I see a bunch of terms being added. So I'm going to think strategically. X cubed, that's the highest one I see right here. So that's going to be first. X squared, so I've got a positive x squared plus 6x squared plus 1x squared plus 6 makes plus 7. X squared, I've got a negative 5x plus 2x. Negative 5 plus 2 makes negative 3x. And then minus 10. Cool. Oops, I'm sorry. Can't even see that. My bad. So I just went through here and I had the 3x cubed. That was the highest power I saw. So I put it first. It was also all by itself. Didn't have any other like terms. The x squared and the 6x squared were like terms. So 1 plus 6 made 7. Here the negative 5x and 2x were like terms. So negative 5 plus 2 makes negative 3. And the negative 10 just drops right there. Okay, a graph given compound inequality in the number line, write it in interval notation. So I've got a negative 3, and it's equal to negative 3. So I'm going to put a solid dot at negative 3, and less than 4, so it's a hollow dot. Remember, compound inequalities, I can always think of this like x is between these numbers. So I graph those two numbers, and I graph everything in between. And my pencil's light, so I won't bother to draw a thick line. I'll just kind of draw a solid connecting from there to there. Hollow dot at 4, solid dot there. Cool. Okay, moving on. Find to determine the following for this line. The x-intercept. Let me think. X-intercept are like these points. Oh, so these are going to be the points where it's the y value is 0. So if I put a y equal to 0 there, that's essentially gone. I get 4x plus 6 times 0 equals 24, but really that's nothing there. Divide by 4, and I get 6. The that should have been up here, right? The x-intercept. The y-intercept is where x equals 0. So if I put in a 0 for x, I get 4 times 0 plus 6y equals 24. That's essentially gone. 24 divided by 6 is 4. What's the slope of the line? Easiest way for me to find the slope of the line, I think, is going to be to change that into slope-intercept form and then just look at the slope number. So if I minus 4x from each side, I get 6y equals negative 4x plus 24. Then I divide by 6 everywhere. I get y equals negative 4/6 x plus 4. That negative 4/6 is what I'm looking for. I will reduce it to be negative 2/3, and there's my answer. Okay, cool. Determine whether the function y h of x equals negative is increasing or decreasing. This function is decreasing. I know that because it's a line, and the slope of the line is negative. That's a good enough explanation. Okay, the value of a car that is 2 years old is $24,500. That same car will be worth only $20,100 when it's 6 years old. Assume the rate of depreciation is constant. You write a linear function labeled fx represents the value of the car at any age. Okay, so I've got a point here. 2 years old, 24,500, and I've got another point that's 6 years old, 20,000. My first thought is, cars don't depreciate just this little, goodness sake. That's stupid, but whatever. So 2 minus 6, that's negative 4. 24,000 fine minus 501 is going to be 400, and 4,400. I can do that division in my head. That's negative 1,100. So that's telling me that my slope, f of x, is equal to negative 1,100x. Now I just need to find the original price. Now, a few ways to do this. I'm just going to look at this. This is 2 years old, right? 24,500. This is telling me it's going down by 1,100, so I'm just going to add 1,100 2 times. This would be 1 year old, and this would be 0 years old. So if I add 24,500, I can't think right now, plus 1,100 plus 1,100, I get 26,700. And there is my function. Cool. Okay, I rewrite this in simplified radical form. 4th root of 16. 16 is the same as 4 times 4, which is 2 and 2 and 2 and 2. I see 4 2s, so I'm going to be able to pull out a 2 there. There are 5 x's, so 4 goes into 5 once, so I'll be able to pull 1 out, and that will leave 1 behind, right? For 7 y's, so 4 goes into 7 once, so I'll be able to pull out 1 y, but that will use 4 y's, so there will be 3 left, right? Remember, 4 goes into 7 once with a remainder of 3. Cool. And z, there's only 1 z, so I can't pull anything out, and it just remains. That's it. Convert the expression to exponential form. Simplify your answer so that it doesn't contain parentheses. And they're talking about the original thing. So this is going to be 16 to the power of 1/4. Remember, the power becomes the numerator, the index becomes the denominator. And this is x to the power of 5/4, y to the power of 7/4, and z to the power of 1/4. So that's my answer, 16 to the power of 1/4, x to the power of 5/4, y to the power of 7/4, z to the power of 1/4. Cool. Okay, that's done. Okay. Whoa, okay, better get up on this a little bit, right? Use the coordinate planes to answer the following questions. Graph the equation of each line, identify the slope of each line, then determine whether each is in function. Well, all lines are functions except for vertical lines. So I don't like that question, but whatever. Graph the equation negative 3/2 x minus 1. That has a y-intercept of negative 1, which is right here, because see, you're counting by 2s, 4s, 6s. And it has a slope of negative 3/2, which means I'm going down 1, 2, 3, and over 1, 2. Rise over run, right? So 1, 2, 1, 2, 3. And I like to do a couple of dots on my lines nice and straight. Otherwise, I might use something like your ID card or something like that to make a line. Okay, graph the equation. The slope is -3/2, and yes, it's a function, duh. All lines are functions other than, say, a vertical line. That would be not a function. Okay, create a table of 3 ordered pairs that satisfy the equation y equals -2. Then graph the equation. X, y, well, y equals -2, so I just need to have y equals -2 on 3 different x values. So I'll just go 0, 2, 4. And I chose 0, 2, 4 because there's 0, there's 2, and there's 4. I could have chosen any x values I wanted. Slope, that's a horizontal line. So the slope is 0. And is it a function? That's a function. Draw a graph that's not a function. All we have to do is do something that violates the vertical line test. I already drew one up there, a vertical line. That's probably the easiest one. But there, that's not a function. It violates the vertical line test because there has inputs that have multiple outputs. Okay. Now, let's get back closer here. Okay. Simplify cubed root of 2y. I can't simplify that. Plus 5 cubed root of 2y. Can't simplify that. Minus 4 times the cubed root of y. Can't simplify that because there's not 3 of anything under there. But these are like terms, right? There's 1 of these plus 5 of these make 6 times the cubed root of 2y minus 4 times the cubed root of y. That's all I can do. Cool. Next question. Sorry, I'm just trying to zip through this quickly. Multiply. Okay, so I'm going to distribute, right? Square root, square root, square root. So they're all the same root, so I can multiply these. So I get the square root of 3 times 4 is 12xy, and then 3 times 5 is 15xz, and it's under root also. But now this 4 was bugging me because I know I can simplify 4, right? Because 12 is the same as 4 times 3, and the square root of 4 is 2. So I'm going to be able to pull that out. So square root of 4 is 2. So this is 2 times 3xy plus the square root of 15xz. 15 came from 3 and 5. There's not 2 of anything there. So there's my answer. 2 times the square root of 3xy plus the square root of 15xz. Cool. Let's take a look at the next one. If f of x equals ax minus 2 and f of 1 equals 8, find the value of a. Well, all this is telling me here, that gives me a point, the point 1, 8. So if I put a 1 in for x, so this is a times 1 minus 2, it will equal 8. So I just put that in, solve it. Add 2, so I get 8 plus 2 is 10 equals 1 times a is a. There's a. A equals 10. Okay. Is the ordered triplet a solution to the following system of equations? Show all the work. So I just need to put that into all 3 of these equations. So I need to go 3 times 2 minus 1 plus 1 equals 6. Put it into there. 3 times 2 is 6. Negative 1 plus 1 cancel. That one checks out. 2x, so 2 times 2 plus 1 minus 1. 2 times 2 is that says it's negative 1. This 1 minus 1 would cancel. 2 times 2 equals negative 1. I don't know why. It's wrong. I know that. Oh, because I'm trying to figure out, is it wrong? Oh. So, no. Second equation don't work. And I know that's bad grammar. I don't care. I don't need to test the third one because as soon as I come to one part that's bad, the whole thing's bad. Okay, cool. Simplify this thing with positive exponents only. So 12 over 18, and I can't think this time of day. 12 over 18 is 2/3. So, and I just typed that in my calculator. x2, x6. So these two cancel out 2 of these and leave me with 4 on the bottom. Y, there's just y's on the top, so y to the 5th. Z's, these 4 cancel out this 1. Remember, there's a 1 there. 4 minus 1 is 3, so there's 3 z's on top, and it does want positive exponents only, so that's done. Cool. Okay. Next. Is this statement never, sometimes, or always true? Explain how you arrived at 3x squared equals 3x quantity squared equals 3x squared. Okay, always true and never true is hard to prove. So I'm going to leave those as sometimes true. Well, I look at these. The 2 applies to the whole thing. The 2 only applies here. So I'm going to test something. Zeros and 1s give us good tests. So if I go 3 times 0 squared, that makes 3 times 0 is 0. 0 squared is 0. And then 3 times 0 squared. 0 squared is 0. 3 times 0 equals 0. So it's true for 0. What about for 1? If I tried 1, 3 times 1 is 3. 3 squared is 9. Good. 3 times 1. So order of operations, 3 times 1 is 3. 3 squared is 9. Okay. 3 times 1 squared. 1 squared is 1. 3 times 1 is 3. So it's not true, not for 1. So that tells me sometimes. It's true for 0. It's not true for 1. I don't care whether it's true for anything else because that's a sometimes, because it's true and not true. Depends on what your x value is. Zeros and 1s find good tests. If you can't see why, you could say the 2 only applies to this whole thing, the 2 applies to this, but that doesn't tell me why it's never, sometimes, or always true. You have to go deeper than that. But sometimes is the easiest one to show because all you have to show is it's true for something and not true for something else. And zeros, 1s, negative 1s, they give me good tests. Okay. Excuse me. Write the expression in radical form. Well, that's not bad. I just have a radical. There's the radicand underneath. Top number is a power. Bottom number is an index. And that doesn't even simplify. So the 12th root of y to the 5th. Cool. Okay. Consider this radical. What would be the most efficient first step? The first step is going to be isolate that radical. So I'm going to add 7, and I get the square root of 2x minus 5 equals 9. Do I have that? That's choice A. Perfect. A. Okay. Rationalize the denominator, right, as a simplified fraction. Rationalize the denominator. Okay. Now, first thing I'm going to do, you can rationalize and simplify, or then simplify and rationalize. I'm going to simplify, then I'm going to rationalize. So I look at this x cubed, square root of 2. That's not going to do anything, but square root of x cubed. There's 3 x's. The index is 2. So I can pull 1x out. That used up 2 of them, and 1 is left underneath there. So 2x. That x cancels. And so I have 4 over the square root of 2x. It's real tempting to cancel out the 4 with 2, but you cannot do that. That's under radical. That's not. So I'm going to multiply top and bottom by the square root of 2x. And I get 4 times the square root of 2x all over this radical now disappears, 2x. Now, I can still simplify. 4 over 2 gives me 2 on top. And so I've got 2 times the square root of 2x all over x. And that's it. This x does not cancel that because this is under a radical. That one is not. Okay. Expand y plus 5 squared. Well, y plus 5 squared is the same as y plus 5 times y plus 5. Y times y is y squared. 5 times 5 is 25. And that's not my answer. But that's what you do if you're not careful. Because you still got to do y times 5 here, which is 5y. And 5 times y here, which is another 5y. There's 2 of those. So 5 times 2 is 10, or 5 plus 5 is 10. Either way, 10. Now, this is a pattern also. You can square this, y squared. Square this, 5 squared is 25. multiply these, 5y, and then double it. 5y double give me 10y. That's a pattern. It's actually really useful to know because this shows up. Cool. Let's move on. Divide this. Okay. So I'm going to set up a tabular division thing. And I don't care whether you use tabular division or long division. Whatever you use, you should be able to do it right. So I'll go m minus 2 there. And then in here, I'm going to go m cubed. So m cubed divided by m is m squared. M squared times negative 2 is negative 2m squared. Negative 2m squared, I need 5. So negative 2 plus 7, that gives me 5, right? Negative 2 plus 7 is 5. That's an m squared. Positive 7m squared divided by m. Positive 7 divided by, it's going to be 7m. 7m times negative 2 is negative 14m. I need to get to negative 23. Negative 14 plus 9. I'm sorry, I'm writing this all in a scrunchy thing here, huh? Yeah, oh well. Negative positive 9m. Negative 14 plus 9 is negative 23. Check. 9m divided by m is a positive 9. 9 times the negative 2 is negative 18. Okay, I need to get positive 16. And I don't have that. That tells me there's going to be a remainder. 34, right? Because negative 18 plus 34, yeah, that makes 16. That's my remainder. So my answer is m squared plus 7m plus 9 plus my remainder plus 34 over the divisor, m minus 2. And that's it. Okay, cool. Moving on. For your high school graduation present, you decided you're going to go rent an exotic car. After gradual experience, you decided on a Lamborghini Huracan. Huracan or Hurricane? I don't know. Because it has 602 horsepower V10 engine, and the Ferrari only has a V8. There are 2 rental agents that have the Huracan. Agency 1 offers the Huracan for $12.75 a day, plus a fee of $5 a mile. So that price, you can afford to what? Take it for a test drive. That would all be me. They probably charge for that. Agency 2 offers it for $1,625 plus $3 a mile. The respective equations are this. So this is for agency 1 and this is for agency 2. For the equation 5m equals 1275, what does the slope of the line represent? That's this first one, 5m. That's the $5 fee per mile fee. For the equation 3m plus 1625, what does the y-intercept represent? There's the y-intercept, and that's for agency 2. That's the 1625 per day. Solve the system of equations. This equation is set up really nicely for substitution. I just need to set that equal to that since C equals both of those. So 5m equals 1275. No, dummy. 5m plus. Sorry, I'm being the dummy. Plus 1275 is equal to 3m plus 1625. So if I subtract 3m from each side, and I subtract 1275 from each side, it helps me balance out the equation. 5 minus 3 is 2m equals 1625 minus 1275. I don't know. 1625 minus 1275. 350. And then if I divide that by 2, I get 175. So m is equal to 175. That's my input value. And since I'm solving the system, I need to solve for C also. So I'm going to take that number and put it into either one of these equations. So I'm just going to go C equals 3 times 175 plus the 1625 gives me 2150. Okay, so cool. And, there you go. Explain how you know your solution to the system is correct. Well, because I did it, of course. That's arrogant, though. Include context as part of your explanation. What are they asking for? Oh, I get it. See, I know it's correct because if I put it into both of these equations, I already tested it for that equation. It's right there in my calculator for the second one. But if I put this 175 into here, 5 times 175 plus 1275 equals 2150. So in other words, what I've done is I've gotten 2150 equals 5 times 175 plus 1275 and 1275, and 2150 equals 3 times 175 plus 1625. So I put that point into both of these equations, excuse me, and it came out to be the same thing. So that's how I know it's true. In context, for each agency, it costs $2,150 to drive 175 miles. So if you're going for a short road trip, you'd want to choose one. If you want to go for a long trip, you want to choose the other. Okay, cool. Let's look something else. That's done. Cool. Last page. Front and back. Okay. A swimming pool in your backyard has a leak. It holds 1,035 gallons of water, but its leaking rate of 45 gallons per hour. Functions describing the amount of water in the pool at any time is leaked by given by that. Find A of 12. So I just got to put 12 into that equation. 1,035 minus 45 times 12. Bingo, gives me 495. What is that? The function describing the amount of water in the pool at time t. So my t was 12. So in 12 hours, the pool will have the amount of water remaining. Gallons, right? 495 gallons in it. Of water. Well, what else would it be? A pool? Jello? That would be messy. What is the practical domain of A of t? Well, the domain is going to be 0 to something. Well, at some point, think of the pool emptying. At some point, the pool's going to be empty. Oh, okay, the pool's going to be empty. When is it going to be empty? Well, it's going to be empty when this whole thing equals 0. So I'm looking at this. This is my starting amount. So 1,035. That's my amount of water I'm starting in, and it's draining 45 an hour. So if I just take 1,035 divided by 45, I get 23. So at 23 hours, it will have nothing in it. Okay? Oh, and that's going to be bracket because it can equal there. So all I really did is I set 0 equal to 1035 minus 45t, and I solved that, and I got t equals 23. That told me that 23... Oh, that's the wrong thing, Tony. No, I'm right, dummy. That told me it's not a point. That's why I was thinking it was wrong. So X, Y, no. That tells me at 23 hours, the pool will have no water in it. Okay? So what's the practical range? That goes right into here. The practical range, the smallest amount of water the pool can have left in it is 0. And the biggest is 1035. Now, here's a classic mistake on here. Since this is a decreasing function, it's going to be looking like that, right? And so we often think its starting amount is 1035, 0. Remember, your domain and range always go from the smallest number to the biggest number. If this is backwards, it is wrong. Okay? Practical range goes from 0 gallons to 1035 gallons. Even though this is the starting gallonage, is that a word? I think so. And this is the ending gallonage. So be very, very careful in that. Okay. Determine whether the function represented following is linear or not. Explain my reasoning. So I just need to make sure it has the same slope from point to point to point. Now I notice here they were nice. 4, 5, 6, 7. So this increases by 1, by 1, and by 1. So you know what? As long as the output value increases by the same amount every time. Sorry, I ran out of lead. I'll be okay. 22.1 minus 22.4. 22.1 minus 20.4, not 22.4, gives me 1.7. So that's going up by 1.7. 23.8 minus 22.1. That's also going up by 1.7. And 25.5 minus 23.8. Sorry, I'm not thinking. I have to use a calculator when I don't think very well. So my rise is always 1.7. And my run is always 1. So the slope is constant. In other words, it doesn't change. Cool. When solving a system of two equations in two variables, the final step yields the quadratic equation 0 equals 5. How many? 0 equals 5. That's an impossible statement. So that means there's no solutions. No solutions. Why? 0 equals 5 is impossible. Impossible for a plane. Sorry, got a song stuck in my head. Okay, so remember, if you end up with 0 equals 0, that's infinite solutions. 0 equals 5, that means there's parallel lines and there's no solutions. Be careful, this is linear equations in two variables. That means we're dealing with lines. If we were doing 3 variables, I would be dealing with planes. Okay, last page. Okay. Cubed root of x minus 11 plus 5 equals 3. Solve the sucker. Isolate it. So I'm going to subtract 5 from each side. And so I get the cubed root of x minus 11 equals 3 minus 5 is negative 2. Now I can have a negative on a cubed root, so that doesn't worry me too much yet. I'm cubing it. So x minus 11 equals negative 2 cubed. Negative 2 times negative 2 is 4 times negative 2 is negative 8. Add 11 to each side, and I get x equals 3. Now, I got to check it. Remember, when radical equations, you must check your answer. Don't assume that's right until you check it. So that gives me the cubed root of 3 minus 11 plus 5. Cubed root of 3 minus 11 is negative 8. The cubed root of negative 8 is negative 2. Negative 2 plus 5 equals 3. That checks. Good. Okay, solve the inequality. Solve the inequality. Write the solutions in interval notation. So I'm going to add 9 to get this by itself. Add 9. That's gone. Negative 3x is less than 21. Less than or equal to 15. Okay, divide by negative 3. Now I'm dividing by a negative. That means my signs are going to flip. So 15 over negative 3 is negative 5. And this flips like this, right? It was less than, now it's not. And this is there. 21 over negative 3 is negative 7. Okay. Now, I can't leave it like that because that's not proper. See, I'm going from a bigger number to a smaller number. So I need to switch the whole thing around. Now, it's tricky a little bit, but see this? See how the alligator's eating the 5? Alligator's eating the 5, and it's equal to there. So these signs are going to swap places too. Not only numbers swap, the signs too. Okay, eating this x. There we go. Alligators are eating the right things every time. Okay, cool. Now, what this is telling me in the interval is it's going from -7 to -5. -7 has a parenthesis, -5 has a bracket. Now, since my answer was in interval notation, if I would have left it like that and then written the interval correctly, I would have been okay. If you would have written the interval backwards, like -5 to 7, in other words, if you would have done this, that is no good because you're going from a big number to a small number. Okay, -5 is bigger than -7. It has to go from small to big. Multiply. Didn't I do one of these already? Okay, 3x squared times x, that's 3x cubed. 3x squared times 4, that's 12x squared. Okay, good. -2x times x, that's -2x squared. -2 times 4, that's -8x. I'm starting to stack these because I know I'm going to combine like terms eventually, right? Okay, -1 times x is -1x. -1 times 4 is -4. And so I get 3x cubed. 12 plus 2, that makes 14x squared. -8 minus x makes -9x and minus 4. And that's it. Cool. Sorry, I kind of squished that over to the side. Last problem. Okay. Multiply this. Oh, simplify this. Doesn't even tell me, but I know I'm going to simplify it. Okay. I'm just going to multiply this and then I'll try and simplify. So cubed root, everything's a cubed root. Okay. So I'm going to multiply these and that gives me the cubed root of 3 times 18. 3 times 18 is 54. 54y. Okay. 3 times 4 is the cubed root of 12 plus 5 times the cubed root of 2y. Okay, I'm thinking cubed root means I have to have 3 factors. 2y, I'm not going to get anything out of there. 12, now I can visualize in my mind 12 is the same as 2 times 6, which is the same as 2 times 3. I've got 2's in there, so if it's a square root, I could simplify it, but this is not. It's a cubed root, so I can't do that. 54, that's the same as 9 times 6, which is the same as 3 times 3, which is the same as 3 times 2. Oh, see the 3's? So this, I'm going to be able to pull a 3 out. I didn't see that. But I'm not going to be able to pull a y out. So the cubed root of, and now I'm left with the 2 underneath, 2y. But check out, these are now like terms. So 3 plus 5 is 8 times the cubed root of 2y. And this cubed root of 12 is left behind. And it doesn't matter which order I write those in. There it is. Okay, guys. Yep, that's the whole test. Thanks.